Now that we have a list of hockey players, and hockey players all have a certain number of points, we can try to decide who's the biggest, which in this case means find who's got the most points. The typical algorithm for doing that would be to start out by making a variable that's going to contain the biggest that we found so far. So for that, we'll go out and we'll grab the first one off the list, the number 0 item. Then we'll go through all of the rest of the players that are on the list. We'll grab the next one off the list. So notice this is a case where a for loop, instead of starting at 0, starts at 1. And the reason it starts at 1 is because we've already grabbed the number 0, 1 off the list. We're going to go through all of the remaining people on the list. We're going to grab whatever number they are off the list, and we're going to turn around and find out how many points that they have so far. So we've got total points for the biggest so far. We've got total points for the one that we just grabbed off the list, and then if for some reason we discover that the one that we grabbed off the list has more points than the one that was on the list, or that we picked as biggest so far, then we'll just say, okay, I guess the biggest so far must be the new one. Notice that it's very important to use the greater than sign there and to write the if statement with the greater than in it, because greater than is the thing that's used for biggest. You could flip this thing around, this expression around, and say if biggest so far points, total points, is less than next one dot total points. But that would be confusing because people would see a less than sign when they expected to see a greater than sign. Now, the problem with this method of doing things is that it's the main program that's doing the work of figuring out that it's points that are important, and I guess we should use points as the way of determining which hockey player is bigger. As with the equals method, what we can do is we can now change that to write a comparison method inside the class and let the comparison method figure out what's biggest actually means. And so what we've done is we've gone in HockeyPlayer and we've written a compare to. The compare to is a comparison of one hockey player against another. What it does is it gets the total points for the current hockey player, which is the one whose variables are declared at the top of the class. It gets the total points for the hockey player which is given to it, and then it takes the difference between their points. And notice that a comparison always returns a number that's plus or minus, where the magnitude of the number in the negative or positive direction tells you how much bigger or how much smaller. So if I weigh 200 pounds and you weigh 150 pounds, the difference is plus 50. But if you weigh 100 pounds and I weigh 250 pounds, then it's minus 150 that you're less than me. Okay? So positive numbers mean bigger when it's a difference, and negative numbers mean less than. If for some reason the difference happens to be the same, then we've got a problem. So the way we do that is with the kick it out sort of style of things. This if statement says, well, if they're already different in points, then we can use points as a way of calculating which one's bigger or smaller. But if they're the same in points, we'll drop through and we'll use the comparison of their first names as a way of checking the difference. Going back to the main program, that means that we still have essentially the same algorithm that we had before, but now it's one hockey player compared to another in order to determine who's the biggest. When you see this expression with the greater than sign over here, the sneakiest thing to do is take that greater than sign and thinking of it as being placed over top of the compare to, so that you can read it as next one greater than biggest so far.